think about fractions is, especially when I'm seeing like 3/4 or 1/2 or 1/4, I like to think of it as decimals as well, or money. So 5 3/4. So if I have $5 and 3/4 of a dollar, I have 75 cents. So it's like saying 5.75 or 5 75 hundredths. Okay, 6.5. Well, I like kind of thinking about 6.5. If I had $6.5, I have $6.50, don't I? So 6.5, if I was to make that a decimal, would be 6.5 or 6 5/10. Okay, and you can see, hey, look, there it is right there, isn't it? 6 5/10. Now, what is between 5.5 or 5.5 and 6? Well, I know that I was going by fourths, 3/4, 1/2. There's a fourth there. So I know that in between 5 and 5/10 is 5 point or decimal 7.5. Okay, so that would be right here, which is the same as 5 3/4. Bad handwriting, I'm sorry. But what that is showing you is that 5 3/4 is right here. Okay, that's this spot right here. That's 5 3/4, or 5 75 hundredths. Okay, now it's my job to figure out, using this frequency table, to make a dot plot. And a dot plot just organizes the information for you. Now, the first thing that you do when you see a dot plot or a stem and leaf plot, we're going to look at this dot plot first, is to read the title. Number of miles James rode his bike each day. Okay. And up here it says James recorded the number of miles he rode his bike each day for 28 days. Represent the data using a dot plot. Okay, so here's our frequency. So on this day, he rode 5 miles, 5 3/4 miles. On this day, he rode 6. On this day, he rode 6.5. And on this day, he rode 7. So on different days, he went different lengths on his bike. He rode different amount of miles. And so we can tell that, how many days did he ride 7 miles? There's 1. Oh, there's 2. There's 3. There's 4. So on 4 days, he rode 7 miles. Okay, so I'm going to look at my dot plot. 1 dot equals 2 days. Okay, so this is 2 days, and this dot is 2 days. So a total of 4 days, he rode 7 miles. Okay, so it really helps me to understand the data that's in this table, because if I look at this, it just looks like a bunch of fractions or a bunch of numbers. So what this graph or what this dot plot is doing is it's really helping me to tell how many miles he rode each day. Now, if I was to ask you, how many miles or how many days did he ride 6 miles? Okay, so the key is, I'm going to look at 6. How many dots does it have? It has 2 dots. Well, each dot is 2 days. So this dot is 1, 2 days, and this dot is 3, 4 days. So 4 days, he rode 6 miles. Okay. Let's see. How many days did he ride? About 8 3/4 of a mile. Well, I know 8 3/4 is larger than 8.5, but smaller than 9. So this is 8 3/4. Well, how many days did he ride that much? There's 1 dot, which is 2 days, and there's the second dot, which is 2 days. So that's 4 days he rode 8 3/4 of a mile. All right, now, so we know how to read a dot plot. We know how to make a dot plot. We're just going to put dots in for every occurrence that happened, okay? Now, down here, this is also a dot plot, but you notice this dot plot is using decimals. Number of miles James rode his bike each day. Well, 5.5. How many times did he ride 5.5 miles? None, because there's no X there. Let's look back up here. Do you see 5.5? No, James did not ride his bike 5.5 miles. That's why there is no X here or no dot. How about 5 and 75/100ths? How many times did he ride his bike 5.75 miles? 1, 2, 3, 4. 4 days. Okay. How many times did he ride his bike 6.5 miles? 2. 1, 2. All right. So if I was to ask you how James rides his bike, what length the most? The most. Okay. So the most is my keyword. And I want to know what the length, how many miles does he ride the most? Okay. So I look at my plot here, my dot plot, and I notice that there's more X's right here. So I know that he's rode his bike more this length, but I need to find this length. Okay, so what's between 6 and 6.5? 6.25 or 6.25, which is 6 and 25/100ths. How many days did he ride his bike 6 and 25/100ths of a mile? 1, 2, 3, 4, 5, 6. Now, guess what? That's also 6 1/4. 6 1/4. Now remember, look up here. 6 1/4 is right here. 1 dot equals 2 days. So there's 2, 4, 6 days he's rode 6 3/4 of a mile. So it's the same way to put data or to create a data plot. However, this one's with fractions, this one's with decimals. This one has each dot is equal to 2 days. And this one, each dot is equal to 1 day. Or each X is equal to 1 day. All right. Now, let's look at stem and leaf. All right. Martin recorded the number of miles he rode his bike each day for 27 days. Represent the data using a dot plot. Stem and leaf plot. Okay. So we have our stem and leaf here, stem and leaf, and our dot plot is down there. Leaf. All right. Sample stem and leaf plot with fractions. So, number of miles Martin rode his bike each day. 5 3/4, 5 3/4, 5 3/4, 5 3/4. So, how many times did Martin right here, ride his bike 5 3/4? Well, how many occurrences are there? 1, 2, 3, 4. 4 times he rode his bike 5 3/4 of a mile. Look, 1, 2, 3, and 4. 5 3/4. So our stem is our ones place, and our fraction is our leaf. And that's how many times it occurred. All right. How many times did he ride his bike? 6 miles. You see where it says 0/4? That just means 0, okay? So how many times did he ride his bike 6 miles? 1, 2, 3. 3 days. 1, 2, and 3. Okay. How many times did he ride his bike 10 miles? 10. 0/4 is still 0. So 10. He rode it 1 time. Now, this is known as your key or your rule to be able to look at and to read your stem and leaf plot. This 5 is represented right here. And here's your line. There's your line. And 3/4. It's telling you how to read it. What that means is 5 3/4 miles. Okay? Now let's look at that in the form of decimals. A sample stem and leaf plot with decimals. Number of miles Martin rode his bike each day. You see, in the stem is 5. In the leaf is 7.5. If you look at the key right here, it says 5, and there's your line, this is your line right here. 7.5 means 5.75 miles. 5 and 75/100th miles. Okay, so that's easier to read. So how many times did he ride his bike 5 and 75/100ths of a mile? 1, 2, 3, 4. There's 4 occurrences. All right, now what are we going to do with that information? We can say, well, looking at this data, how many times did he ride his bike? All right, so how many times did he ride his bike? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. 27 times. All right. Well, I want to know how many times did he ride his bike greater than or more than 6 miles, but less than 7 miles. So greater than 6, not equal to 6, greater than 6. Okay, so I'm going to look at these. Greater than 6, but less than 7. So I'm only looking at these numbers, okay, which is 6.25, 6.25. That's this one right here, 6.25. This is 6.25. This is 6.25, 6.25, 6.25, 6.25, 6.25, 6.5, and 6.5. How many times? 1, 2, 3, 4, 5, 6, 7, 8, 9. He rode his bike greater than 6 but less than 7 miles 9 times. Okay, now what fraction of that did he ride out of the entire time he recorded his ride? Well, he recorded how many days? 27. Okay, so he recorded 27 total days. And out of those 27 total days, 9 days he rode greater than 6 but less than 7. Okay, so that's 9/27. Or we can divide the top and the bottom by the same number. Let's reduce this fraction. 9 divided by 9 is equal to 1. 27 divided by 9 is equal to 3. So 1/3 of the time, he rode his bike greater than 6 miles and less than 7 miles. 1/3 of the time. Interesting. All right. How many days did he ride more